Okay, let's just dive right in. Welcome to a truly epic, absolutely mind-bending explainer. Today we are embarking on a journey that starts right here on our tiny blue dot of Earth and zooms all the way out to try and grasp the true scale of infinity. I mean, Earth is our home, right? It's where everyone you've ever known, every human who ever lived, and literally every story ever told has existed. But what happens when we look up and just keep zooming out past our atmosphere? Well, prepare yourselves because we're about to take a journey to explore the staggering dimensions of the cosmos.
And that brings us to the central question driving our entire explainer today. How big is our universe really? It sounds like a simple question, but the answer is so vast, so incredibly enormous, that it honestly tests the limits of human comprehension. So as we prepare to leave our comfortable atmosphere, flying past the moon, past the sun, and out into this immense cosmic ocean, we're going to start with what's relatable and scale up step by step. Let's get started.
All right, Section 1, the cosmic backyard.
384,000. That is the distance to the moon in kilometers. This is our first massive, yet still somewhat relatable benchmark. It's the gap between us and our absolute closest celestial neighbor, the very place humanity first stepped foot on another world. But to truly understand a number that big, we kind of need to bring it down to Earth.
To really ground that staggering distance, I want you to imagine getting into your car and driving on a magical cosmic highway at a constant speed of 100 kilometers per hour. No stopping for gas, no traffic jams, no pulling over to sleep, just pure driving. It would take you over 160 days of nonstop driving just to reach the moon. Think about that. Over 5 straight months of travel just to cross our closest cosmic gap. But the scale quickly jumps, 150 million. That's the distance to the sun in kilometers. So from a few 100,000 kilometers, we are suddenly dealing with hundreds of millions. This massive gap is the space that the warmth and light of our star has to cross just to keep our planet alive.
This 150 million kilometer distance is so fundamental to understanding our solar system that scientists actually gave it a special name, an astronomical unit, or AU for short. It's basically our baseline cosmic yardstick. Even light, which is the fastest thing in the universe, traveling at an astonishing 300,000 kilometers per second, still takes over 8 minutes to cross just one single astronomical unit and reach us. To really anchor this vastness to human reality, consider this. We know light takes 8 minutes, right? But what if you boarded a standard commercial jet and flew directly toward the sun? At normal cruising speed, crossing that single astronomical unit would take your commercial jet 19 years. Just let that sink in for a second. A 19-year flight just to reach the center of our very own solar system.
Moving on to Section 2, to the edge of the solar system. Okay, the scale jumps again, this time to 4.5 billion. That's the distance to Neptune in kilometers. Neptune is this distant, dark, freezing ice giant. Remember how we said sunlight takes 8 minutes to reach Earth? Well, way out here, 4.5 billion kilometers away, it takes sunlight more than 4 hours to reach Neptune. From that perspective, our sun is really just a particularly bright star in a very, very dark sky. But here's the crazy part. Neptune isn't actually the edge. The true boundary of our solar neighborhood is the Oort cloud. It's this vast theoretical sphere of icy objects that basically encloses our entire solar system. This is the ultimate boundary, where the sun's solar wind is finally stopped cold by the pressures of interstellar space. And the scale? It's breathtaking. It spans nearly 2 light years across. This right here is the true final frontier of our solar system, the massive buffer zone where our cosmic journey into the wider galaxy actually begins.
Which brings us to Section 3, Interstellar Wilderness and the Milky Way.
So beyond our sun's reach, our absolute closest neighboring star system is Alpha Centauri, sitting roughly 4.4 light years away. For light, it takes 4.4 years to make the trip. But what about us? Well, our fastest spacecraft, Voyager 1, is currently hurtling through space at mind-boggling speeds. Yet even for Voyager 1, traveling to Alpha Centauri would take over 70,000 years. It's almost hard to wrap your head around, but it perfectly illustrates the sheer, isolating scale of interstellar space.
Now let's zoom out from our local stars to look at the grand scale of our entire home galaxy, 100,000. That is the diameter of the Milky Way galaxy in light years. Within this massive swirling spiral, there are hundreds of billions of stars. We're talking hundreds of billions of potential solar systems swirling around in a disk that takes light 100,000 years to cross from edge to edge.
Okay, prepare to have your perspective totally shifted. Humanity has been broadcasting radio signals out into space for about a century now. That means our human radio bubble extends exactly 100 light-years in every single direction. Compared to a 100,000 light-year wide galaxy, our entire civilization's footprint is just a microscopic, barely there dot. Beyond that tiny 100 light-year sphere, it is as if humanity never existed at all. To the rest of the galaxy, it is completely, entirely silent.
All right, moving into Section 4, Cosmic Webs and Superclusters.
Let's break down the galactic hierarchy for a second. First, the Milky Way belongs to the local group, which is a cluster of about 50 galaxies spanning roughly 10 million light-years. Sounds huge, right? But zoom out further. That entire local group is just a tiny fraction of the Virgo supercluster, a titanic collection of literally thousands of galaxies. Our entire galactic neighborhood is barely a speck within this supercluster.
And guess what? We aren't done zooming out yet. 500 million. That is the expanse of the Laniakea supercluster in light-years. Laniakea actually means immense heaven in Hawaiian, and honestly, it's pretty easy to see why. Stretching over 500 million light-years, this structure contains our Virgo supercluster, along with many, many others. It's this massive cosmic web of attraction, glowing with billions of interconnected nodes.
So, what exactly binds this immense heaven together? Well, it's something called the Great Attractor. It's this incredibly mysterious gravitational core right within Laniakea that anchors the massive cosmic web of the supercluster. It is literally pulling billions of stars and entire galactic clusters toward an unseen gravitational anomaly. We are all right now flowing along these invisible cosmic rivers straight toward the Great Attractor.
And finally, Section 5, the infinite beyond. 93 billion. This is the staggering, almost unbelievable diameter of the observable universe in light-years. It is an absolute astronomical marvel. From our tiny blue dot, looking out in every single direction, this 93 billion light-year sphere is the absolute physical limit of what we can see. It contains every supercluster, every galaxy, every star, and every planet that light has actually had time to reach us from since the very dawn of time.
Which leaves us with one final, ultimate question. But what lies beyond it? The truth is, the actual size of the entire universe remains a total unknown, and it's potentially completely infinite. Because the universe is expanding, some regions out there are actually retreating from us faster than the speed of light. That means the light from those incredibly distant places will literally never reach us. They are placed forever out of our sight. So the observable universe? That's really just the part we are permitted to see.
I want to wrap up this explainer with a really humbling thought. We are part of an ever-expanding masterpiece, standing on a small speck, gazing out into a beautiful, endless infinity. We started today by looking at Earth, and now, stepping back, we see it for what it truly is. A small, miraculous speck in a vast, silent, and possibly endless ocean. Thank you so much for taking this incredible journey of scale with me today. Keep wondering, keep asking those big questions, and I'll catch you in our next explainer.